Okay, hello everyone. It's Mr. Widmeyer here, coming to you from, well, Friday, recording for you guys here on Monday. All right, I know I told you guys that we were going to be doing reflections today, but I decided that since we didn't quite get as far as I would like to on rotations, we're going to finish up rotations. You'll be working on the assignment here in class, that way you don't have to take the protractors home, and then tomorrow, which will be Tuesday, we'll do reflections. Okay, so block 1, you guys only got through number 4. Wait.
Mike Mummert, please dial 67254. Thank you.
So you guys only got through block 1. You only got through number 4 here, and blocks 2 you guys got through example 4 and 5. Either way, I'm going to go ahead and go through the rotation here with number 5. That way you can kind of just remember, what to do with these rotations, refresh your memory a little bit, because I know it's been since Friday that you guys saw this. So hopefully this will help you remember. Okay. At this point, you should have your book in front of you. Turn to page 90. All right. You also want to have a piece of this parchment paper. All right, if you lost your parchment paper, or the patty paper or tracing paper, whatever you want to call it, there is more up by the protractors up front that you can use. Please do try to hold on to it and use it more than once. I'd rather not waste it and then have to make a whole bunch more. Not that it's expensive, it's just a lot to do. So anyway, so hold on to these pieces of paper and go ahead and get those things. If you don't have protractor, tracing paper out and your book out, then go ahead and pause the video, make sure everyone gets that taken care of, but everyone should have that taken care of. I'm going to have that in the directions. So anyway, let's get into our example here. Okay, so what I want us to do is we're going to rotate here. The directions say for number 5 to do a clockwise rotation of 125 degrees around point Q. All right, so here is point Q, our center of rotation. I can kind of zoom in on that here some. There we go. All right, and so in order to do this, we're going to use our straight edge of our protractor and connect one of our vertices of our triangle here to that center of rotation, point Q, like so. All right, then we need to decide how we're going to be rotating. So again, a clockwise rotation, so you have to think about Q as being the center of our clock. Clockwise, okay, is that going to go up or is that going to go down to go clockwise here? Well, if we go the direction of a clock, it should go up in this direction. This is clockwise right here. Okay, so we want to go this direction 125 degrees. So I'm going to erase my little arrow there. So we'll line up our protractor on point Q. Okay, and again, we have to decide, all right, what set of numbers are we going to use? On our tool here, right, there's inner numbers and there's outer numbers. Well, since the side of our angle that we're trying to make is right here, we should be starting at 0. So there's 0 right there. So we want these outer set of numbers. All right, I'm going to count all the way up to 125. So there's 120, there's 130, and so I have to count these little tick marks. So 1, 2, 3, 4, 5. Oh. Okay, there it is. And we're going to draw from Q to that point our line here that's going to help us guide our rotation, like so. All right. Now we have the 125 degrees down there. We're going to take our tracing paper here. I'm going to kind of X out these previous constructions that I've done. And all we need to trace are the vertices of T, U, and S, and also point Q, and then connect SQ just like that. All right. Now that we have those points drawn, I'm also going to draw on the back of those points that I just drew. So right there, right there, right there. And this is going to help us transfer those points. So flip your paper back over, check just to make sure that those are there. Okay, very good. And then we're going to rotate our paper around point Q, rotate, 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 until it matches up with the 125 degree angle. There it is. And I'm going to draw on the back, draw on the back, draw there, and it should transfer the points over. Oh, I didn't do a very good job there, but it poked through at least, so I can still see it. And then we connect the dots. using our straight edge. If you're having trouble in your book, you can tear these notes out. There'll either be a stapler up here at the front of the room, or you can also go to my desk and the stapler could be there as well. Because it's kind of hard to do these constructions with the pages in the book like this. The book just it's just so thick. Right? But there it is, rotated. Ooh, and now that I'm looking at this, I think I did the wrong one. Yeah, it should be this point right here. This is where sometimes I shouldn't be reusing the paper like I did because it kind of created an error there, but that's okay. I'll fix it here. There it is. That looks like the triangle we're supposed to get. So this is going to happen to you guys. Sometimes you're going to like miss your points or mess up your points or something like that, and you're going to need to know whether you make a mistake or not, whether you made a mistake or not. I knew this triangle was wrong because I could see clearly it had changed. All right? It did not look like this original triangle. We know that a rotation is a rigid motion transformation, which means the size and the shape of our original figure should not change when we rotate it. And it did. So that means I knew I made a mistake. All right, let's go ahead and label these points S prime, U prime, and T prime to indicate that they're transformed from S, T, and U, respectively. Okay, and there's our successful transformation. All right, let's continue on here then. So that's what we're going to transform. Now the next section we're going to look at talks about drawing rotations on a coordinate plane. All right, the good news is it's not much different from what we just did before. Okay, the bad news is, if you're having trouble with it, well, we're going to do some more here, so you get some practice at least. Okay, so it's not that much different from what we did before, but at least you get some practice. All right, so drawing rotations on a coordinate plane. So it turns out we can rotate a figure by more than 180 degrees. If you guys remember, we talked about what it means to rotate by more than 180 degrees, and we're going to look at that here. I'm going to kind of skip their explanation here and move on. Here are rules that you can use to help you do rotations around the origin in the coordinate plane. All right, we are not going to have to memorize these things. I'm going to have you guys use the patty paper to do these constructions. But if you want a quick reference to see the coordinate notation for these different rotations, okay, all of these rotations are counterclockwise, including the 180 and the 360. And so you can use these to kind of help you if you want to just take your points and then transform them this way. So all of these different transformations are described right there in coordinate notation. Okay, so number 2 asks us to draw the image of the figure under the given rotation. Quadrilateral ABCD, and we want to rotate that 270 degrees. Now, there is not a given direction here for that rotation of 270 degrees. So we're going to assume that is a 270 degrees counterclockwise. If you're not given a direction, assume counterclockwise is the way that we are rotating here. Now, we're going to be rotating around the origin. So if you look here at ABCD, all right, here's the origin right there. I'm going to go ahead and put some points there on A, B, C, and D. All right, we're going to connect A to D, or sorry, not A to D, A to the point of rotation, the center of rotation, which is the origin there. So I drew my little segment. All right, and now we're going to take our protractor and we want to draw a counterclockwise. So counterclockwise would be going this direction. So we want to go this direction 270 degrees. Now, when I go to line my protractor with the center at the origin, okay, you can see that I got to put my protractor on this side, okay, on this side of the angle. So I'm going to rotate that 270 degrees. But what's the highest number that my protractor goes up to? Yeah, the highest number my protractor goes up to is 180. I can't do a 270 degree angle on my protractor. So we have to sit here and think. If I want to go 270 degrees this direction, how many degrees is that going in the opposite or clockwise direction? So again, I want to figure out, if I want to go 270 degrees in the counterclockwise direction, I need to figure out, since I can't do 270 degrees on my protractor, I need to figure out what exactly, one second.
If you're in the building, can you stop by the athletics office? Thank you.
I need to figure out exactly what measure I should go in the clockwise direction. There's got to be a clockwise way to go instead of going counterclockwise 270 degrees. And the way we do that is we think, okay, to go a full rotation, a full complete rotation, that's 360 degrees. All right? 270 degrees takes me some of the way around, so if I subtract off 270 degrees, that leaves me with 90 degrees, and that is the clockwise direction. So you can either go 270 degrees counterclockwise or 90 degrees clockwise. And that's the way we're going to go. Okay, 90 degrees clockwise. So I'm going to erase the direction here now, and we're going to instead go 90 degrees clockwise. And so to go 90 degrees, it's actually pretty simple because 90 degrees is exactly, if I line my protractor up here, right, again along this side, we're going this direction. Now 90 degrees is right here, so it's basically rotating from the y-axis down to the x-axis. Okay? So we're going to rotate straight to right here. I'm going to try and draw this in here as best I can. 90 degrees. Okay, there it is. And then we'll just trace our figure here. So point, remember, center of rotation, points A, B, C, and D. Okay, and we're going to connect A to the origin just like it was. And then we just rotate it down here. All right? And then we're going to transfer those points. And they should match up to grid points. If they were on grid points here, they should be on grid points down here. So there's A right there. Okay, and we can try and see if we can do these points to transfer. They didn't quite transfer. But here it's kind of easier to see what those points are. For example, I can see that there's a point right here at 2, so I'm just going to go ahead and put that point down there. All right, there's another point at 4, -1, so I'll just go ahead and peel my paper back and put the point at 4, -1. There's another point at 1, -3, so I'll put that point at 1, -3. And there's also a point at 2, -4. And so I'll peel my paper back and just go to 2, -4, and then connect those dots using your straight edge here. All right. And so there's the 90-degree clockwise rotation, which is also really 270 degrees counterclockwise. Okay? We should label our points too, so let's see here. A rotated 90 degrees this way, right down to here. So this point right here is A prime. Okay? B rotated down here to B prime. C is right here, C prime. And then D prime is the remaining point. And there's how you do a rotation in the coordinate plane. It's just like we did before, except there's just the grid lines there now. Okay? And if you go over here on the next page on 91, you'll see that there's the answer. Okay. A to A prime, B to B prime, C to C prime, D to D prime. All right? Let's try this next one here. Letter B, we want to rotate triangle KLM 180 degrees. Okay. So again, we'll put some points here, some vertices on K, on L, and on M. We're going to connect our closest point there to our center of rotation, which is the origin, so we'll connect K to right there. And we're going to rotate 180 degrees. Again, we're not given a direction, so here we're going to assume it's 180 degrees counterclockwise. But actually, when it's 180 degrees, does it really matter whether we're rotating counterclockwise or clockwise? If you rotate 180 degrees, be it counterclockwise or clockwise, where do you end up? Either way, you're going to end up looking direct. Like if you actually just stand up and rotate 180 degrees, you would end up looking in the exact opposite direction from where you started. 180 degrees is just merely turning around. And so it doesn't matter whether you rotate 180 degrees counterclockwise or clockwise, you'll still end up in the same position. So for 180 degrees, the direction really doesn't matter which way you go. But we're going to assume counterclockwise because, like I said, anytime you're not given a direction, assume counterclockwise. Okay. So let's go ahead and mark in our 180 degree angle. So put your protractor on the center of rotation there. Okay. We're going to start measuring from this side, so 0 degrees, but it's easy because from 0, there's 180. It's just the exact opposite direction. So we'll go ahead and mark that off, 180 degrees. Okay, like so. There's 180 degrees. Counterclockwise. All right. And then again, scratch out our old work there. Okay. And we'll copy this one down. So again, transfer or copy the point of rotation, the center of rotation, and the vertices of our triangle. Connect, again, that center of rotation to your nearest point there. And we're going to rotate. The sound effects are very important for me to do these, otherwise they just don't work the same. Nah, I'm just kidding, you don't need the sound effects. Anyway, there are our 3 points we want to transfer over. So again, I'm just going to kind of identify. Okay, we have a point at -1, 4. I'm going to peel my paper back and put a point at -1, 4. We have one at -4, 1. So again, I'm going to peel my paper back and put the point at -4, 1. And then -2, 1 is the other point. So -2, 1, there it is. So all lined up. And now I'll connect those. And actually, I'm just going to freehand this since it's so close together. Voila. Okay, there's our rotated triangle. We want to again identify our points that have been transformed. So if K was the closest one here, this one means is the closest, so it's K prime. Here L is going to rotate all around here to L prime, and here M rotates all around up here to M prime. So there's our triangle. All right. Also over here, it asks us to fill in the coordinates for K prime. So like I said, K prime has coordinates -2, 1. L prime has coordinates -4, 1. And then M has coordinates -1, 4. Okay. You can actually see here the coordinate notation. Look at what happens for the 180 degrees. You can actually come up with the coordinate notation for this transformation just by looking at how your coordinates change. I'll zoom in a little bit more here. Okay, notice K to K prime, what's changing? 2, -1 becomes -2, 1. What happened? Well, they just switched signs. 2 went to -2, -1 went to 1. Same here with L. 4, -1 went to -4, 1, and same thing with M. 1, -4 went to -1, 4. So what's our coordinate notation here? Well, we take our point XY, and it's just the opposite. So there's the coordinate notation for that transformation. Okay. If we go back over here to our previous one, letter A, the coordinate notation for this one is a little bit trickier, but you can still see it. Okay, so for example, if you look at how A to A prime changes, okay, all that seems to change there is that they switched. 0, 2 became 2, 0. But then if we look a little bit closer at B to B prime, 1 and 4 becomes 4 and -1. So they did still switch, but that Y coordinate became the opposite of what the X coordinate was. Same thing here for C. C was 4, 2, and then C prime becomes, again, switching 2 to the -4, and again, the positive 4 became a -4. Here, same thing, D, 3, 1 becomes 1, -3. So our coordinate notation will be something like this. We're going to take XY, we're going to swap the Y and the X, like that. Oops, it's off the screen. There we go. But we also need to make sure that these become negative numbers here. So we're going to put like that, negative. And really by negative, I mean they become opposites. If this 1 had been a -1, then this would become positive 1 here. If this 4 had been -4, it would be positive 4, so on and so forth. So that's the coordinate notation for the 270 degree rotation counterclockwise. And you can check to see that's true. There it is, Y -X, right? If you go back up to the table here that we have, there's the 270 degree rotation counterclockwise. XY goes to Y -X, just like what we had here, XY to Y -X. So we can identify our coordinate notations without even having to memorize them. We can just kind of do them and then see what happens. Okay? All right. Turn the page to page 92, and you'll see there's two examples for you to try on your own there. So why don't you go ahead and give those two a try. Rotate triangle PQR 90 degrees, and then triangle or quadrilateral DEFG 270 degrees. And then if you would please pause the video, and when everyone has a chance, about 5 minutes or so, to try these two problems, 5 minutes max really, then unpause the video and we'll go over these two together. So go ahead and pause the video now. Okay, welcome back. Hopefully you had some luck with doing these two rotations here. Again, I'm going to go through these rather quickly because you should have already tried them on your own. Triangle PQR here, we want to rotate this 90 degrees, again counterclockwise. We're not told the direction, so we assume counterclockwise. So there's P, there's Q, and there's R. Again, we're going to connect point P. I'll zoom in some on this. Okay. To the origin, which is always our center of rotation when we're doing coordinates. Okay. Then we're going to rotate 90 degrees. So I have to put my protractor down here, center at the origin, going through point P there, and I want to measure off 90 degrees, so right there. And let's see, we'll get this lined up. Okay, there's 90 degrees. I'm going to copy my center of rotation, copy points P, Q, and R there, and also connect P to the center of rotation. Rotate it so that lines up. There we go. So it looks like I have a point at 3, 4. I also have a point at -1, 4. And I also have a point at -1, 2. And then I'll connect those dots. Like so. Okay, P goes to P prime here, Q goes up here to Q prime, and then R rotates up right here to R prime. And there's that 90-degree angle of rotation right there. Okay, so there's where P prime, Q prime, and R prime should be. Quadrilateral DEFG, we want to rotate that 270 degrees. Again, we're going to assume counterclockwise. I'll just abbreviate there. CCW. Alrighty. So again, we're going to put some points on D, E, F, and G, and our center of rotation there, the origin. I'm going to connect E to our center of rotation. And then we're going to measure 270 degrees counterclockwise. So now let's see here. Counterclockwise means I'm going to be going this direction. But again, the problem with 270 degrees is that's not on our protractor. So we're not going to go 270 degrees. We can't. But remember, instead of going 270 degrees this direction, we can go how many degrees in the opposite direction? Well, again, 360 minus 270 degrees is equal to 90 degrees. But we're going in the opposite direction, so instead of going counterclockwise, we're going to go clockwise. So that is the direction we want to go. So instead of going counterclockwise 270, I'll erase this, we'll go clockwise 90 degrees. So let me set my protractor up here on the correct side. There's 90 degrees. And we'll again connect the dots here. There's my 90-degree angle. All right, I'm going to copy my center of rotation and the vertices again. Draw my little segment. Rotate it 90 degrees so that, boom, it lines up now. And I can see I have a point at 1, 3. I have a point at -4, 1. I have another point at -3, 3. I have another point at negative 1, 1. Okay, so there's the rotation of my quadrilateral. This point is D prime. This point right here is G prime. We have F prime right there. And then this point, I'm going to have to put an arrow in there because you can't really see it otherwise. E prime. And there it is rotated. Again, this is 90 degrees clockwise, but you also think of it as 270 degrees counterclockwise. Okay? All right. We have one more thing to do, and that is to look at identifying angles of rotation. And this is super easy. So we saved the easiest thing for last here. Some of you guys are probably thinking, good thing, because this is ridiculous. All right. Find the angle of rotation and direction of rotation in the given figure. Point P is the center of rotation. So if you look here at letter A, we already have a rotation done for us. So like the hard work is all taken care of. We just have to figure out what the center of rotation, or the angle of rotation is. And it's so easy. All you have to do is start off just like we have done in the past by connecting A to your center of rotation, or any point really. You can B to this P, A to P, C to P, whatever. I'm picking A to P because it's the closest. Now, since we connected A to P, A rotates to make what point? So again, what point does A rotate around P to become? Well, it's got to rotate to make A prime. And so we need to then connect P to A prime as well. Okay. If you chose to draw B to P, then you would want to connect P to B prime. If you chose to draw C to P, then you would connect P to C prime, and D to P would be P to D prime. All right. There is our angle of rotation right there. So all we have to do is use your protractor and measure that angle of rotation here. So let's see. Line my protractor up. And I can see that, ooh, it's kind of hard to see. I'm going to extend my side here. I'm going to extend that thing, that line right here. Because it looks like it's, I think I have an idea of what it is, but I want to extend my line. So now when I line my protractor up, we can see here that my line goes right through. Ooh, there's two numbers here. Is it 80 or is it 100? Which one is it? Well, again, think about our side of our angle here. We started on this side of the protractor. Does it make sense to start our angle at 0 degrees or 180 degrees? Of course, we should be starting at 0 degrees. So we open it up, and then 80 is the measurement there. So this is an 80 degree. And what direction is it? Well, it's counterclockwise. If you want to abbreviate that, feel free to write CCW. Okay, and there's the measure. 80 degree counterclockwise rotation around point P. All right. Instead of rotating 80 degrees counterclockwise, though, keep in mind here, right, we could, if we wanted to be kind of like, smart about it or cute about it, I guess, we could say, well, or it rotated this direction, so we could also say clockwise it rotated, but how many degrees? Well, if it's 80 degrees this way, it's going to be 360 minus 80 degrees the other direction, which is 280 degrees. So you could also say 280 degree clockwise rotation if you wanted to be cute. Okay, I'm assuming most of you, though, just want the most straightforward approach. But there you go. All right, let's look at letter B. All right, letter B, I'm going to have to zoom out some because it doesn't quite fit on the page there. We're going to do the same thing. Wait, letter B, yeah. Letter B, we're going to do the same thing here. We're going to measure this angle of rotation. So again, let's connect Q to P because that's the closest point there. So Q to P, just connect the dots. And P to Q prime, connect the dots. Okay? So we're going from Q to Q prime, so we're going this direction with our angle of rotation. And so I'm going to turn my page, I'm going to measure along this side using my protractor. Line it up. Okay. So Q, my angle of rotation starts on this side, so I should start with the 0 degrees, and I'm going to count all the way around over here to, you know what I forgot to do? I didn't extend my side far enough here, so I'm going to have to extend this segment so I can like actually read it on my protractor. Hopefully that's far enough there. Line it back up. And I get it to go right through here, which looks like it's 131, 2, 3, 4, 134 degrees approximately. And again, what direction is this? Well, this is clockwise. So 134 degrees clockwise. Alternatively, right, we could have rotated this direction. And how much would it be? Well, again, a full circle is 360 degrees. This piece is 134, so that means the rest of the other direction here would be 360 degrees minus 134 degrees, okay, which is, let's see here. 6 would get me to 140, so 226. 226 degrees counterclockwise. Again, if you wanted to be cute. All right. Final example down here, number 11. Okay, I know it says your turn. We're going to do it together here real quick just to show you. All right. Connect, let's see here. It's your choice, N or K. I'm going to connect N to point P. So N to P, N prime to P. All right. We're going to measure here, so let's see. We're going from N to N prime, so I'm going to go this direction. So I got to turn my paper here. There we go, and adjust it. Line up my protractor. Ooh, it barely fits, but it does. That's good. Okay, if I look here, it looks like it's falling right along this ray, which leads to the 70/110. But of course, since we're starting here, the 0 is at the outer side of numbers, so it goes up to the 70. Okay, I'm going to extend my side just to check to make sure, though. Sure enough, 70 degrees is what it goes through. So we'll say it's a 70 degree clockwise rotation. And of course, alternative to that, instead of going 70 degrees this way, we could go the whole way around here in a counterclockwise way, and it would just be 360 minus 70, which is 290 degrees, or 290 degrees CCW, counterclockwise. Okay? All right. So, your assignment, I'm going to go ahead and give that to you now. So if you turn the next page, what I'd like you guys to do for the rest of class, you have some more practice here to do with some rotations. So on page 95, I want you to do numbers 2 and 3. Number 4, so all those are just practicing your rotation. I want you to do number 5 and 6 as well, more rotation practice. 7 and 8, 9 and 10, 11 and 12 as well. Notice here in 11 and 12, it asks you to write an algebraic rule for the rotation shown. What that means is you need to come up with, okay, when you're done, you should have an x, comma, y, arrow, and then you need to fill in the coordinate notation here. My suggestion, list out the points, D, E, F, and G. So put point D, E, F, and G right here. List their coordinates. And then list the coordinates for D prime, E prime, F prime, and G prime. And note how the D point changes to D prime, how E changes to E prime, how F changes to F prime, and how G changes to G prime. Once you see that pattern, then say in general this is what's going to happen. Do the same thing for number 12 as well. All right. In addition, I'm going to have you try number 14 and 15, and then number 17 as well. And that'll be it. Your substitute will write these problems up on the board too, so you don't have to worry about if you missed any of those. Okay? Have a great day, guys. Get your work done. This is not going to be homework if you don't finish it, because I can't let you take home the protractors, so you need to finish it in class. okay? So take the rest of the class to finish these up, and I will be checking this tomorrow to see that it's done, okay? And you may not take the protractors home, once again, because we need those for the next class. Have a great day, guys. We'll see you tomorrow.